Good morning, this is Dr. Turner for Fundamental Mathematics. Today we're going to be talking about 6.4, which is looking at converting from standard to scientific notation. The conversion from scientific to standard notation, or standard to scientific notation, is going to rely primarily on this idea of base 10. Now, we talked about this a little bit in 6.2 when we introduced the metric system and the fact that it is a decimal or base 10 system. The idea between converting between standard and scientific form is going to rely on the same principle, but we'll go ahead and get started and see what that looks like. So when you look at scientific notation, you're always going to be, of course, looking at a base of 10 and an exponent like we did in 6.3. And then your coefficient has to be somewhere between 1 and 10. It can be 1, but it cannot be 10. So with that in mind, when we start out with a number, and it could be big or small, let's say I start out with 615,000, for instance. My goal is to convert this to be some value times 10 to a power. That's what we want. Now, there is a method behind the madness, but essentially all we're doing is going to move the decimal. Remember that when you multiply by 10, as we said before, you're moving the decimal to the right. And if you're dividing by a power of 10, all you're doing is moving the decimal to the left. With that in mind, we're sort of going the opposite direction. So I have a large number, 615,000, and I want to condense that into being multiplied by X number of tens. So all you're going to do is you're going to take 615,000 and you're going to move the decimal until you have a number that's between 1 inclusive and 10. So here, I would start here at the end, and I would go from the end 1, 2, 3, 4, 5 places. By moving the decimal 5 places, I end up with a decimal of 6.15. That number is between 1 and 10. Therefore, this is 6.15 times 10 to the 5th power. And that's all you have to do. You're going to move the decimal X number of spaces until you end up with a decimal that is between 1 and 10. Doesn't matter how big or how small the number starts out. It could be 150 million, for instance. Same thing. You are looking for some value times 10 to a power, and you're going to move the decimal at the end until it is between 1 and 10. So you'd start here and go 1, 2, 3, 4, 5, 6, 7, 8. By doing that, you end up with 1.5, which is between 1 and 10. That is times 10 to the 8th power. Now, you could end up with more than 2 significant digits like I've shown here. It depends on what the problem is. You could have multiple decimals. It really just depends on what you're given. And it could be something that's very small, for instance. So let's say I have the number 75 and I ask you to convert it to scientific notation. So, same thing. You're converting it to a number times 10 to a given power. So 75, move the decimal, boop. All you have to do is move it once. That is 7.5 times 10 to the 1st power. Now, those are easy enough, right? You're moving the decimal to the left, X number of spaces. A lot of students have an okay time with that. However, let's say you had something that's already between 1 and 10. Let's say you start out with 3.75. Okay, well, this is a decimal that's already between 1 and 10. So for this value, you don't need to do anything. You can just write 3.75 times. And because you're not moving the decimal at all, this would be times 10 to the 0. Now, we said at the very beginning of 6.3 that scientific notation is used to convert very small or very big numbers. So far, all we've really done is convert very big numbers. Well, what about very small numbers? So with small numbers, it's going to be the same process. However, you're going to move the decimal in the opposite direction. So for instance, 0.001,875. Same goal. You're going to move the decimal until you have some coefficient times 10 to some power. So here, moving to the left isn't going to do anything for me. It's going to continue to get smaller and smaller and smaller. So for a problem like this, I need to actually move the decimal in the opposite direction. I need to move it to the right. So I move the decimal to the right, 1, 2, 3, 4 spaces. By moving it 4 spaces, I end up with 1.875. Now, I wouldn't want to put times 10 to the 4th power because that would indicate it's a big number, right? Anytime I multiply by 10, the number is getting bigger. Here, the number is very small. So instead of having a positive 4, what we do is we put a negative 4 because dividing by 10 4 times, we need to move that decimal over to the left. And we'll look at that when we talk about 6.5, converting from scientific notation to standard form. Let's look at another one. Let's say I have 6.00000093. So again, some coefficient times 10 to some power. I'm going to take the decimal wherever it is, and I'm going to move it until I have a number between 1 and 10. So 1, 2, 3, 4, 5, 6 places. That gives me 9.3. I did move it 6 times, but because this is a very small number, I want my exponent to be negative. And last one, let's say I have something like 0.01. Remember, you have to continue moving it until the decimal is between 1 inclusive and 10. So here, I would move the decimal 2 places to get 1 or 1.0. You don't have to add the 0, but you can. I move the decimal 2 times, and because it is a small number, that is times 10 to the negative 2nd power. That's it for today, guys. If you have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.